Hello, good evening, and welcome to another video with Mosaic Tutors. Today, we will look at indices. Indices. Now, it is very popular for you to see something like 10 times 10 times 10 times 10 times 10. Now, there is a very shorter way of writing this. So you don't need to write all the whole 10, and it is very easy. All you need to do and just pick one 10 instead of 10. Then how many times they appear? 1, 2, 3, 4, 5. So you just put the 5 small for up here. So this is a shorter way of writing this, which means this one means 10 5 times. In other words, if I see 2 raised to power 3, it means 2 3 times. So I get something like this. So this means index form, which means 2 carry 3, 10 carry 5. For English, they call am 10 raised to power 5 or 2 raised to power 3. For you to understand the concept, if person dey drive very good, the person wey carry for back na him actually be the boss. So that is how we dey call this one the boss. So 10 is carrying this one, so you raise am. So 10 is raised to power 5. Now the most important thing we dey look today is the laws of indices. We dey look at the laws of indices. In other words, if one index number dey add another index number, I know say that one na big grammar. What I mean be say if one number wey dey carry another one dey add another one wey dey carry one, how we go take do am? For example, if you get 2 wey carry 5 and you multiply am by 2 wey carry 3, how we wan take do am? The shorter method of doing this na to write this 2 5 times, to write this 2 3 times, then you come start to dey solve am. But instead of going through those process, we go look for shortcut wey we go follow, and that go lead us to the first law of indices, which is multiplication. Now, when I write multiplication, for inside bracket here, I go put plus, and you go see the reason why I put plus for inside bracket here. So make we look at this example. If I get a raised to power x and I get times a raised to power y, how I go take solve something like this? Now remember this plus wey dey for here, the law just talk say if one index or one letter or number wey dey carry another one, if e dey multiply another letter or number wey dey carry something for up, then we go choose one of the two of them and we go add the power. If dem be the same, we go choose one. If dem no be the same, we go multiply the one wey dey down, then we go add the one wey dey up. Make I show you wetin I mean. So this one go become, because a and a na the same, I go pick one a, then the two up plus, remember, so I go say x plus y, as easy as that. Make we try am with numbers. So for example, if I get 2 raised to power 5 plus 2 times 2 raised to power 3, wetin this one go give me? Na the same 2, so I will just pick 1 2, then come up here 5 plus 3, and 5 plus 3 na wetin? 8. So that go become 2 raised to power 8. E dey very easy. Now the question is, what if no be the same? For example, if I get 4 raised to power 2 times 3 raised to power 4, wetin I go do? Because this down no be the same, I go multiply am 4 times 3, then for up, I go come add the 2 wey dey up, which is 2 plus 4. 4 times 3 na 12, so I write 12. 2 plus 4 na 6, so I write 6. So the law for this multiplication, if the 2 down na the same, pick one, add the powers. If the 2 down no be the same, multiply am, add the up. And so that will take us through the laws of indices for the point of multiplication. Now, what if no be multiplication? What if na division, which is the second part, division. Now, for division, as I put plus for here, I go put minus for here. Aha, I know you don dey guess already. Yes, if you dey divide, instead of plus, you just minus. So make I use this same set of numbers. Okay, let's use the letter first. So if I get a raised to power x times a raised to power y, the process no dey difficult. Since na the same thing, I go pick one. Then instead of adding, sorry, na division we dey do, so this one go be divide. So I go pick one of the two, then wetin I go do to the powers, I go subtract the powers. Remember in this case, multiplication, this one na division. For multiplication, I dey add the powers, but for division, I dey subtract, I dey minus the powers. That's why you bring am here. We go do the same example now. So for example, if we get x raised to power 5 divided by 2 raised to power 5 divided by 2 raised to power 3, wetin that go give us? Because these two no be the same thing, I go pick, because these two na the same thing, I go pick one, which is 2. When I pick one between these two wey dey for up, because say na division sign dey here, I go subtract or I go minus am, so that will be 5 minus 3, and that will be 5 minus 3 na 2, so that is 2 raised to power 2. Make we work with this one wey we don do before, make we see if we go fit get this answer. So make we work with these two, make we divide this one by this one, so make we go number 2. So number 2 we get 12 raised to power 6 divided by 3 raised to power 4. Now because no be the same thing, we go divide am, no be the same thing. So you get 12 divided by 3. Then for this up here, na division, so we subtract the up, so that is 6 minus 4. And that will give us wetin? 12 divided by 3 na wetin? Na 4. 6 minus 4 na wetin? Na 2. And if you look up here, na wetin we get here. So the law no just dey difficult. If na multiplication, all you need to do na to do wetin? Na to add. While if na division, you need to subtract. Now one other rule na, if the down na the same thing, for English dem dey call am base. If the base, which is the two down, na the same thing, just pick one, add the powers. But if the base no be the same thing, then e also dey very easy. Multiply the two base and then add the powers. Now the question is, what if in cases whereby I get base wey no be the same thing and base wey be the same thing joined together? We go see example on that. So we go do for multiplication first. So what if I get something like 2n raised to power 4 multiplied by 3n raised to power 2? Now before I explain this example, note that when you see something like this, nothing concern this 2 with this 4. Nothing concern that 2 with the 4. Now this n get the 4, the 2 no get any power. Except if you see 2n, then dey inside bracket, then 4, this one mean say na the two of them dey share the 4. So this one, if you open the bracket, 2 go collect a 4, n also go collect a 4. But in this case, na only n get this 4. The same thing here, these 3 no dey share this 2, na only n na im get the 2. So with that knowledge in mind, we go come solve this question. Now, if you notice, these 2 dey different, while these 2 dey the same. Now remember the rule: if dem dey different, multiply them. If na the same, pick one. These 2 dey different, we go multiply them. These 2 na the same, we go pick one. So make we multiply these 2 wey dey different first. So that is 2 times 3. Now n and n na the same, so pick one n. Then wetin we go do to the powers? We go add. So that's 4 plus 2. We dey add because na times na im dey here. 3 times 2 na wetin? 6. Then put the n. 4 plus 2 na 6. And you get your answer like that. Make we try the same thing for division. So what if we get 15x raised to power 4 divided by 3x raised to power 3? In this case, na division. If you see the one wey no be the same, divide am. If you see the one wey be the same, pick just 1. So we go do the same thing for here. So these two no be the same, we go divide am. These two na the same, we go pick 1. So you get 15 divided by 3, then these two na the same, so that is x. Then we go subtract the powers, which is 4 minus 3. 15 divided by 3 na 5. Then you come back to your x. 4 minus 3 na 1. You fit decide to write am like this. You fit also decide say you no wan write am. It's all left to you. So if you write am like this, you get 1 here, or you fit leave am as 5x. Na the same thing. So this is just the process involved. So with this now, I dey sure say we fit solve any question wey gat to do with multiplication and division. Na the zero index. They dey call am the zero index. And this law show say anything wey carry 0 for up, the answer na 1. Na just direct law, which means if x carry 0 for up, the answer na equal to 1. Now I know say you go dey ask yourself, how dem take come about that law? How e dey possible to say anything wey carry 0 na 1 for up? Well, I go explain am, but before then I wan make you understand one concept. In mathematics, e get this thing wey we dey always do. If a dey equal to b and b dey equal to c, e mean say a dey equal to c. So we fit see am in form of a triangle. A dey here, b dey here, c dey here. If e dey equal to this, then this dey equal to this, then this dey equal to this. I just want this just background knowledge for wetin I wan explain. So if a dey equal to b and b dey equal to c, e mean say automatically a dey equal to c. We go come back to this rule. So now for us to fit prove this one, we go use equation in division to prove say x raised to power 0 go give us 1. Now if you get x raised to power 3 divided by x raised to power 3, e get two ways wey we fit take solve this one. The first way na by expanding. We know say x raised to power 3 divided by x raised to power 3 na the same thing as x raised to power 3 over x raised to power 3. If we break this one down, it means x times x times x over x times x times x. You can agree with me. Now because this na x, we fit divide. X here 1, 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 x here 1. So in this case, we get 1 times 1 times 1 over 1 times 1 times 1, which give us 1 over 1. 1 times 1 times 1 na 1. 1 times 1 times 1 na 1. So 1 over 1. 1 over 1 na 1. So in this case, x raised to power 3 divided by x raised to power 3 give us 1. Now the same x raised to power 3 for here divided by x raised to power 3 for here, we see another answer wey e fit give us. Now we say if the two of them dey the same, if we dey divide, just pick 1 and also go to the power, we go minus am. So that is 3 minus 3. 3 minus 3 na wetin? 0, which means x dey raised to power 0. Now in this case, x raised to power 3 divided by x raised to power 3, we solve am, e give us 1. X raised to power 3 divided by x raised to power 3, we solve am, e give us 0. How we come fit tell say x raised to power 0 dey equal to 1? Like the concept wey I used before, if a dey equals b and b dey equals c, e mean say a dey equals c. Make we use the same concept here. So x raised to power this one will be the question, we go label am a. Now when we solve a, the first answer wey we get na 1, we go label am b. Now we we'll come back and solve a again. The answer wey we get na this one, x to the power 0, we go label am c. Now if a here give us this answer, that means a dey equals to b. So we don get a equals to b. A equals to b. Now the same a here, now we solve, e give us this answer as c, which means a dey equals to c. Now if a dey equals to c, e mean also say b dey equals to c, which means this one dey equals to this one, c dey equals to b. So x raised to the power 0 dey equal to 1. x raised to the power 0 dey equal to 1. Na why we say the law of the zero index say x raised to the power 0 dey equal to 1. Now why dem bring dis rule? Because you don't have to go through all this stress of solving this question. Whenever you get the question wey dey of indices, just apply the rule. Anything raised to the power 0 go give you 1. So when you get 100 raised to the power 0, your answer na 1. You get a raised to the power 0, your answer na 1. You get 44 raised to the power 0, your answer na 1. You get 4,432 raised to the power 0, you still get 1. You get 1 million raised to the power 0, the answer na 1. Anything at all raised to the power 0, you go still get your answer as 1. Now this will lead us to the last law for indices. The last law for indices. The last law for indices na negative index. Negative index. Now if you look through wetin we dey solve since, the numbers wey dey for up na always positive numbers. For those of us wey no know positive numbers, we can watch other videos. Number wey no get minus na positive numbers, plus numbers. So now what if the number wey dey for up come get minus? For example, if you get x raised to the power minus 3, if you get x raised to the power minus 3, wetin you go do for here? The law dey very simple. In mathematics, in index, you no fit work with negative index. You no fit work at all. So you have to find a way to change am to positive index. And the only way to do so na say this minus go change to 1 over. Only the minus go change to 1 over. Then you go rewrite this equation without the minus. Because the minus don already change to this one, the minus no go dey again. So you go come get x raised to the power 3. Make I explain that concept again. So when you get something like this, x raised to the power minus 3, in index, you no fit work with minus. So you have to find a way of changing the minus to plus. Because of that, the minus wey dey here go change to 1 over. If the minus change to 1 over, then you come get the normal equation for here without the minus, because the minus don already change. So that will be x over 3. X raised to the power 3. 1 over x raised to the power 3. Now like the last one, the zero index, we also fit prove say this dey equal to this. Make we use this question to prove am. If you get x raised to the power okay, so if you get x raised to the power 2 divided by x raised to the power 5, x raised to the power 5. Now there are also two ways of working this one out in such that this go dey equal to this. No forget that concept of the a equals b and b equals c, then a equals c. And the same concept we will use for here. Now two ways of solving this one. One na by expanding. In other words, expand this one. X raised to the power 2 over x raised to the power 5. This will give us x times x all over x times x times x times x times x. Now if you begin dividing, x cancel x cancel x. Wetin remain? X here na 1, x here na 1, x here na 1, x here na 1. So you don get this already. So this gives you 1 times 1 na 1 all over 1 times 1 na 1. 1 times x na x, x times x square, x times x cube, or 1 2 3 s, take the s, put 3 for up here. So this question now don give us 1 over x raised to the power 3. But you get another way of solving it again. When you get x raised to the power 2 divided by x raised to the power 5. Now according to the law of indices, we say the only thing we need to do now is to pick 1x. When you pick 1x, this up 2 will subtract this one minus 5. And that will give us wetin? X 2 minus 5, big one minus small one. That will give us minus 3. Now we don solve this one, we get this answer. We don solve this one, we get this answer. Using the same concept, a equals b equals c, which means a equals c. This one we label am a. Our first answer we label am b, and our second answer we label am c. If a give us b, that means a equals to b, And now A for here also give us C, that means A equals C. If A equals C and if A equals B and A equals C, that means B equals C, that means B equals C, that means C equals B, which means x raised to the power minus 3, x raised to the power minus 3, they equal to 1 over x raised to the power 3. And the rule we talked about before. Negative indices, change the 1 to 1 over and write the number 1 for here, and you are good to go. Thank you for watching this week's video, and I'll see you next week.